Okay, so continuing our journey through HackerRank. So here we go. Let's do this one. This one is ice cream parlor. So two friends like to pool their money and go to the ice cream parlor. They always choose two distinct flavors and spend all of their money. Okay, given a list of prices for the flavors of ice cream, select the two that will cost all the money they have. Okay. The two flavors, so each one selects two flavors, or they always choose two distinct flavors. Okay. So an example is M is 6 and cost is 1, 3, 4, 5, and 6. So the two flavors that cost 1 and 5 meet the criteria. Using one-based indexing, they are indices 0 and 4. Okay. So we are to return. Select the two that will cost the money they have. Okay. So I just want to find something that adds up to that value, right? So complete the ice cream parlor function in the editor below. Ice cream parlor has the following parameters: the amount of money and how much. Okay. So the indices of the pieces of flavors they buy are sorted ascending. So it's sorted in ascending order. So I should be able to do something which is similar to what would that be? I feel like there's a two-pointer solution to this, right? So there should be. Let's think about this. So if it's sorted in ascending order, what we can do is I can have pointer 1 is equal to 0 and pointer 2 is equal to 1 because they have to be different, right? And now no, I want pointer 2 to be at the end. So I'm going to say length of array minus 1. Okay, like this. So now if I want something cheaper, I go this way. If I want something more expensive, I go this way because I want to use all my money. So I'm going to say while P1 does not equal P2, right? So we don't want them to be here, and so this is a bad condition. So I'm going to say if array indexed at P1 plus array indexed at P2 is equal to our target, which is M, then we want to break right here. Okay? Otherwise, if array, and is it guaranteed that there will be something that matches this condition? There will always be a unique solution. Okay, fine. So if this value here, the sum of the two things that we selected, if this is too big, greater than M, so if that's too big, I want to decrease it. I want to make it smaller, right? So how am I going to do that? P2 minus equals 1. And then likewise, if this is too small, I want P1 to increase. P1 plus equals 1, right? And array, just verifying, is sorted, right? The cost of each flavor. I thought I saw something about it being sorted. So I think it said yes, but I will I also want to practice, make sure that I remember how to do the sorting thing. So it was, because there's two different ways. There's dot sort and then there's sorted in Python. And I need to stick to one convention. Was it array dot sort like this? And is that in place, or do I need to capture it? I cannot remember. We're gonna have to investigate that here. But anyways, we're gonna keep doing this, and then once we break out of the while loop, we should be able to say, does it want us to return it or print it? Returns an int. Okay, so I can say return, and then the first one is going to be p1 plus 1. The second one is going to be p2 plus 2, like this. I'm just going to see if it runs and if we're good. Wrong answer. Why is that the case? One. So the two flavors are at meet this criteria using one base indices that are index 1. Okay. So 1 and 4, 1 and 2. And now I'm saying 1 and 3, is that right? Or 2 and 3? And 1 and 3, okay. So 1 based indexing. This one, P1 is moving over, P2 is moving over, okay. This is working, or it should be working. This is dumb. Let's see. My output is 2 and 3, 1 and 3. So why are there two numbers? Why are there like two rows actually? Oh, is it the two test cases? No. That's the one above, right? 1, 3, 4, 5. Index 1 and index 4. 1, 2, 3, 4. 3, 4 is cost of 4, okay? Okay. It's 1 and 4, yeah, that makes sense. So now for mine, which is incorrect, I come here and there's two things here, so I'm saying index 2, so 1, 2, this 3, okay, plus 5, 1, 1, 2, 3, 4, 5, so 7, 8, 9, 10. Okay, so that's not right, obviously. Print. What do I want to print? I guess this right here. Like this, right? Aye, come on. Print formatted string like this, and then I say like this, and then formatted string again like this, and then I'm just gonna say m like this. Okay, so let's run our code and see it. Okay. Alright, so 2, 2, and 4. Okay. So we're getting 2, 2, and 4. And is there a 2 and a 2 on this one? Here, right? Which should be at index 1 and index 2, which is equal to 4. Yeah, that... But I'm giving 3 for some reason. If I break out here, P2 should be there. Oh. That's index. This is before I do the plus 2. Why am I doing a plus 2? Do I not have internet? Probably. I don't know. Okay. Great. Good. Okay. Fine. If the array is sorted. So is it not hold on. That was one of the questions that I said, but I didn't even verify that. Is it not sorted? 1, 4... Okay. I thought it said that it was sorted somewhere. So, I'm going to try this. Is this the correct way to sort? Nope. Let me just actually, instead of just doing random things like that, what is the correct way to sort things? No. Just show me index array dot sort. Okay, so dot sort. It should be right then. Okay, just paste this back in with that hashtag moved out. Okay. Yes, come on, come on, come on. Just tell me how to do it. Just tell me why Yo, why did my sort not work? Like, that's what I want to know. Is destructive to the original positions in your data. When you call this, the number... However, the problem asks you to return the original indices. Oh, that's annoying. Okay. Okay, that's kind of annoying. So, original... So there are two sort methods in Python. What are they? And what is their difference? And then I just need to memorize one and just have that memorized. Okay. Both organize your data and behave very differently in terms of how they handle memory and what they return. So, list.sort and the sorted function, yes. So list.sort, the in-place method. This method belongs specifically to list objects. So sort belongs to the list class of objects, right? It's a method within the list. It modifies the original list directly and does not create a new one. Okay, so this is the normal one. This is the in-place one. So sort is in place. Returns none. Behavior, it overwrites the original list. Okay. Okay. This one, built-in function that takes an iterable. So I don't want to learn this one. I only want this sort. And that's all that I'm going to know. I'm not going to know anything but sort. This does not exist. Whatever that is, I don't know, I don't care. I don't want to know it because I don't want to get confused. So, array here, good. So now I'm going to say, I need a... Okay, so I need to keep track of the indices, right? Dang. So, what I can do is have some kind of like dictionary or something. Like that maps. Okay. So, I'm gonna have... And what am I gonna call this? I'm gonna call it... like... sorted to original, right? Is equal to here. No, it's equal to here. So the key is going to be the sorted index, and the value is going to be the original index. Okay. Like this. So now I want to go like this. Sorted array is, get rid of this, is equal to a new list, right? And then I'm going to say for element in, no, I'm going to say for index in array in range length array, like this. Okay. And I want to add this to my dictionary. So, can I say sorted to original indexed at, the key is going to be the sorted. No, hold on. How am I gonna do this? I don't know. I actually don't know. Because what I want to do is map the... What I want to do is map the index, but that's going to be changing all over the place, right? So when I sort things, it's going to change it. Darn. Okay. So, how do we do this? For I in range here. Okay, so I guess I can just come back to here. So let's just look at it. So we take this list, we append the value and the index to it, okay? And then we sort it by the first element, which is the value and the index, okay? Alright, so let me, not this one, let me come here, and let me try to get rid of this, right? So, sorted list is equal to a new list, like this, and so now I'm going to say for I in range length of array here, then I'm going to say sorted list is equal to dot append, right? And then I am going to say what? I'm going to say a tuple with the first element as array indexed at I, and the second one is going to be just I, and then they're doing the plus one because that's the answer, okay? And then what I can do is I can say here, like, sorted list dot sort, because that's the only one that I know, okay? And now, anywhere that I have this array, I just press here. Okay. Like this. And then this doesn't really matter. I'm not going to look at that anymore right now. And then I can return... Let's see. So if they're equal to each other... Then I return a list of sorted list indexed at P1, right? But I want the 1th element. Same thing here. Sorted list of P2, but I want the 1th element. And then that means that I want the 0th element here. Okay. 0th. 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 Let's see. No! Okay. Back to Google. Ascending order. HackerRank expects the indices to in ascending order. Okay, instead of 4-1. Works. The standard convention of true pointers is here. It's slightly safer because it prevents it. But I'm only doing one thing per time. Dot sort. Okay. Like this. No! Okay, fine. We come right back to it. Keep everything the same. Only change what will make it successful. Comment what you changed. Oh my goodness, I hate this. I hate leak code. It just makes you feel so stupid all the time. In your return line, you wrote this. Yes, the problem is in place. It returns none. Oh, okay. Currently none. Madawaka. Okay. It should do this in place. My dumb list is equal to this. Now, my dumb list dot sort like this. Return my dumb list. I like how I'm just preemptively doing this because I think it's good. Okay, it did. It passed. Okay, great. Oh, that was obnoxious, and I feel like I should have been much better at that than I was. I am very disappointed in myself. Awesome. So, what do I need to know? What do I need to remember? First off, I completely got bad at this idea of, like, keeping the indices in place when I should have remembered that I can just use a tuple and then sort on the first index. Like, that's a trick I need to drill into my head. I need to have this sort in my head. This sort also operates on the first index, so that's what I need to also remember. The other thing is I was doing something which was like a dictionary, and then I was let's actually just force that to fail. So I'm gonna say my dictionary is equal to this, like this here, and then I said, like, my dictionary indexed at the key, let's just say, is 2, right, is equal to haha, right? I think that this is going to fail, so print my dictionary indexed at key 2. I think that this is going to fail. Let's do that and then ask why. It did not. So what is the difference between this and like a default dictionary? Okay, because I thought that was going to fail. So let me come here. I thought that this was going to fail, but it worked the way I thought. I thought only a default dictionary could do this. I'm curious if it can understand what I'm saying, because I always do the little whisper thing. Plus, I'm just not frustrated, but just like I want to be going faster, and I don't feel like I'm going fast enough. Would do this. What is the difference between the dictionary and the default dict in Python? See, it could understand what I said. Okay, so right now what I'm trying to do is kind of clear out some cobwebs that I have in my brain that are just like in there, and I feel like if you clean out cobwebs, you're able to, the other stuff kind of just falls into place. So that's what I'm trying to do right now, is I feel like I kind of understand a lot of the algorithms, a lot of the data structures, but I need to put things together. I need to make sure that I just like, oh, okay, that little trick, this little trick, I know exactly how sort works, I know exactly how all of these things work. Okay, so this one, a standard dictionary is strict. So here works because you're telling Python, create this key and put this value in it, okay? If you're trying to print a key that you haven't assigned yet, it will crash. Oh, okay, okay. Here we go. So I can create a new one. Okay, so it's not at runtime, or it's not at creation time that you need to do it. I was thinking something slightly different. I was thinking it was kind of like an array, that if you declare an empty array in like C or something, and then try to access or like add a new element, it will crash. But this one is for a normal dictionary. If you index, if you try to index, or if you try to print something, index something that you haven't created yet, then it fails. Okay. So a default dictionary is forgiving. When you try to access a key that doesn't exist, it doesn't crash. Instead, it automatically creates that key with a default value. Okay. You have to tell it what kind of default you want. That's why we have that thing there. Okay, so like default dict is an int, which defaults to 0. Okay, this works. Okay, awesome. So let's whatever. Let's I guess we have to submit this again so that we get that little button to move on. Okay, next challenge. So, ooh, all right, a grid problem. So, L knight is a chess piece that moves in an L shape. Okay, we define the possible moves of L knight as the movement from some position x1, y1 to some x2, y2, satisfying either of the following. So x2 equals x1 plus or minus a, and y2 equals y1 plus or minus b. Okay. x2 is this, but swapped those. Okay. Note that a and B and B and A allow the exact same set of movements. For example, the diagram below depicts the possible locations that knight L12 or knight L21 can move to form this current location on a 5x5 chessboard. Okay. Observe that for each possible movement, the knight moves 2 units in one direction, horizontally or vertically. Okay. And 1 unit in the perpendicular direction. Okay. Given the value of n for an n by n chessboard, answer the following question for each AB pair, where AB is between 1 and n. Okay. What is the minimum number of moves it takes for knight to get from position 0 to position here? If it's not possible for the knight to reach the destination, return -1 instead. Then print the answer for according to the output format. Okay. A single integer denoting n. Print exactly. If n equals 3, we organize the answer for all ij pairs in the output like this. picks a location that KnightL can move from its current location. Okay. What is A? A and B. Allow the exact same set of moves, for example. Okay, but what is A and B? It's not passed in as a parameter. I don't know. So it's just between 1 and n. They give n, so okay. What is the minimum number of moves it takes to get from position? Print exactly n-1 lines of output in which each line... Okay. Awesome. So I have no idea how to do it. Okay, there's a little bit more. Let's just see. The diagram below depicts the minimal path for KnightL11 and KnightL12 and KnightL13. One minimal path is this, okay? Then we print here 2 1 1 1 1 1 1 1 1. Okay. So is this like a backtracking problem? But I would need some way of... Yeah, okay, cool. I have no idea how to do this, so we're going to put it into Gemini, and I should have said, hold on, I have no idea how to solve this problem. Can you walk me through the steps of thinking about what this problem is even asking? Understanding the problem, thinking of the algorithm to choose, and then applying it. Finally, give me some suggestions on what I should study to better rise myself with these kinds of problems. Okay. This is a shortest path on grid problem. So, number one, understand the problem, the translation. The setup, you have a chessboard of size n by n. You're on the top left corner, okay, 0, 0, and you want to get to the bottom right corner. Did it actually even say that, though? Like, where did it say that we're at the 0, 0th position? Okay, here. What is the minimum number of moves it takes for knight AB? Again, AB is abstracted, it's not a real thing. To get from position 0, 0, so we are at 0, 0, to position n-1, n-1, okay? And that is past n, that's real. If it is not possible, return -1. Okay, So, yep, the twist. Instead of a standard knight, which moves 2-1 in L shape, you have to calculate the answer for every possible L shape, where the jumps are A units and B units. Okay, you need to test the combination so all of the different combinations. For each pair, find the minimum number of moves. The goal: print a grid matrix where each entry is the shortest path from that specific AB knight. Okay, so choosing an algorithm. Why breadth first search? When the problem asks for minimum number of moves or shortest path, every move that has the same cost, 1, we should use breadth first search. Okay, that kind of makes sense because I remember doing like Rotten Tomatoes or something where we would do bing, 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 and each thing was a time interval. So that kind of makes sense to me. Breadth first search is like a ripple in a pond. It explores all spots you can reach in 1 move, and then all spots you can reach in 2 moves, and so on. The first time the ripple hits the destination here, you are guaranteed that it's the shortest path, okay? So, to solve for a single pair AB, initialize a queue, and we need to do this for every single pair. Initialize a queue, put your starting point in with a distance of 0, okay? Keep a visited set, don't step on the squares twice or you'll loop forever. Okay, yeah, that makes sense. Define 8 possible moves. Okay. Loop through the query until the queue is empty. Okay. Otherwise, look at the 8 neighbors. Okay, add it to the queue. If the queue runs out, return -1. So, let's see. Get min moves is we have this queue, row column distance, visited is a set, okay, the moves here. While queue, we get the next one, but how does this get every single combination of AB? Oh, okay, that's here. Okay, that's in like the main logic. Okay, so whatever, def find min, and this is going to be for AB, right? And we're going to say we want to do breadth first search for the combo of AB. Okay, so doing a breadth first search is another thing that's like super important, but obviously is not second nature to me, and I need to get it to that point where, so I know that I'm gonna have a queue is here, and I am going to be at 0, 0, and I know that they did distance, but I'm thinking about why this would be the case. And why are you angry though? But never used. Well, that should be okay. So x, y, distance, like this, okay? q dot, so yeah, it's upset something here. Then import collections. Okay. Wait, but I misspelled this, but what? Okay. Okay. So HackerRank is just not very responsive towards that. I think LeetCode is better, that it just like automatically does that. That's fine. Now are you happy? Okay, so I also need a visited array. Visited is equal to 0. Wait. Multiplied by n, right? Is equal to 0 is equal to this list, okay? So 0 for blank in range in for blank in range in, like this, okay? And now I want to while q here, and then I say square is equal to q dot pop left. Yeah. Okay, so I got the q, or I have the square, and now I want to look at the 8 possible combinations. So I want to say, so we did we have those, I'm going to say moves is equal to this, and it is going to be something like this. So 1, 2, oops, come on. 1, 2, 3, 4, and then copy and paste this. Actually, I'm going to say A, B right here, okay? And I'm going to come here. Like this. So A is negative and B is not negative. Okay. A is negative and B is negative, right? Or neither one is, but we captured that right there. So now I say B is negative. Is that it? I thought that there were 8 combinations. I don't know, man. 真的是讨厌这个 LeetCode， 我不想做 LeetCode。So, I don't think that this is correct, but whatever. It's going to reveal some gaps in my knowledge, so I guess that's okay. So what I can do is for move in moves like this, if square, so I want to check the x direction, right? 0th index plus x and y, kind of like this, plus x is greater than, or is smaller than or equal to 0, and square indexed at 0, it plus x is greater than n, and the same thing but for y's. Then what I can do is say q dot append, and then I want to append my this one as my x, okay? I want to append this with my y, and then I want to say like that distance, so square of distance plus 1, kind of like that, okay? But I also want to say and this here not in visited, okay? So I don't want visited to be like this. It's equal to a set. This, okay. So now I'm going to say visited.add this. I don't know. Not visited. It's right there. It's right there. You just stop complaining. Quit your complaining. Okay. Okay. If square indexed at 0, indexed at 1, is equal to what? N minus 1 and square indexed at 1 is equal to N minus 1 return we found the shortest path. Okay. I don't know. What do I want to return? I have no idea. I have no idea. Square index at 2. Sure. It's not correct, but at this point I'm just gonna say this. I don't know. Otherwise we just return -1. I'm kind of, I just want to take a break. I just want to take a break. Initial creates a queue with 3 separate elements. 0, 0, okay. You need to wrap your starting state in another list or tuple. This way you can pop left and get the whole coordinate system at once. Can flip A and B. Okay, whatever. Boundary check has 2 issues. Oh, okay, so I can change that. Okay, well, that means, so it didn't like this, I did this incorrect, I didn't do these correctly. And I don't even know if I'm answering the question correctly either, because I don't know, what is it trying to get me to output? Print exactly N-1 lines of output. What is that supposed to even mean? I don't know. I don't know what it means. Let's make each respective J cannot reach position. Okay. So what I think I'm gonna do now is take a break from this, try to watch some videos maybe about these kinds of problems, and then from there come back and see if I can do a better job on this. So I'm gonna come back to algorithms, right? And so this is when I wasn't, so I selected specifically sorting, and then it came out with, oh, did I lose it? Oops, I don't know. Where was the one that I was just doing? Oh, maybe it was search. Hold on. This one right here. Okay. So we were doing a search one, right? So I can find it again. And then Maybe we do more just like, was it general problem solving or something? And see how we can improve our skills. Yeah, I wish I had more time to be practicing this. Okay, so I think that's the way that I am going to go about this. Thank you guys for watching. If you want to subscribe, you can do so. Join me on my journey, and my name is Timothy Lee Grant. I'll see you guys in the next video.